Yes. Good morning, ladies and gentlemen. Thank you for finding the time to attend today's conference. Before we begin, allow me to introduce myself. My name is Kevin O'Brien from ITS. I will be succeeded by another Master of Ceremony, Placidus Christadi Stefan Nugroho. We will be your Master Ceremony for today's event. The Joint International Conference on the Third Sustainability and Resilience Coastal Management, or abbreviated as SRCM, is an international conference held by the three research centers at ITS, namely the first one, Research Center for Disaster Mitigation and Climate Change, PUSLIT MPKE. The second, Center for Sustainable Infrastructure and Environment Research, PILB. And the last one, Research Center for Marine and Earth Science and Technology, PUSIT STKK. This year, the third time SRCM has been held, and this conference takes the general theme of the sustainable and resilient coastal management, considering that Indonesia is archipelago and the most of the people are concentrated in coastal areas but are accompanied by the environment conditions. The quality of the increasingly polluted environment and an increasing frequency of natural disaster in Indonesia are certainly topics that need further discussion. In addition, the issue of the climate change needs to be raised because it causes this portal. Because it's the coastal areas of the area the most vulnerable social life is also the problem in this location, especially with the condition of the COVID-19 pandemic, which will increase the amount of poverty and residents in coastal areas where most are their livelihoods are fishermen. In an effort to protect the environment and maritime affairs, especially for archipelagic areas such as Indonesia, to become an area that has a clean environment, changes in the community environment that are able to adapt to conditions that occur both environmentally, socially, and economically. Thank you. The Honorable Director of the Directorate of Research and Community Service 2022, Associated Professor Fadlilatul Taufani, SD, PhD. Our colleges, partner universities abroad in Philippines, Malaysia, England, United Kingdom, and Honorable Keynote Speaker, Professor Daniel and Professor Harry. Honorable Presenter and distinguished audiences, we are delighted to welcome you to the third Sustainability and Resilience of Coastal Management. Corresponding to the nature of the event, I would like to read the protocol of the online conference. The first, participants are kindly reminded to rename the display name of the Zoom participant ID as shown in the screen. For example, Kevin underscore ITS Surabaya. In addition, please turn on your camera throughout the conference and use the virtual background listed on the link. And the second, participants are requested to be dressed and to behave in a polite manner. The third, participants are requested to mute their microphone along the duration of the online conference. Number four, participants are reminded to kindly set the online conference environment to be comfortable and optimal for camera activation in terms of backlight. Number five, participants are recommended to make sure the internet connection is stable along the online conference. Number six, participants are recommended to use headsets or earphones to minimize noise. And the last one, participants are prohibited to distribute the link in any way or form in any individual, party, or institution. For a brief moment, we would like to invite our distinguished guests and audiences to listen to the Indonesian national anthem, Indonesia Raya, and the hymn of Institut Teknologi 10 November. Ladies and gentlemen, kindly please mute your microphone, and especially during Indonesia Raya, please stand up. Okay, thank you for the song. Continuing the next session, we will be start with an opening remark delivered by Mr. Aci Pamungkas, ST, MDev, PLG, PhD, as the chairman of SRCM 2022. To Mr. Aci Pamungkas, the time is yours.
Bismillahirrahmanirrahim. The Honorable Director of Research Center and Community Services, Dr. Fadilatul Taufani, the Honorable Keynote Speaker, Prof. Daniel Mudiarso, Prof. Heri Kuswanto, and Dr. Andrea J. Rosa, and respected presenters, particularly from the Philippines, Malaysia, and UK, and also the Indonesian partners, participants, and all my colleagues as conference committee. Assalamualaikum warahmatullahi wabarakatuh. One good morning to all of you. I, as a conference chairperson, welcome every one of you to the conference SRCM 2022. In this opportunity, I also offer my special thanks to all the keynote speakers who have already prepared to share their opinions, experiences, thoughts, and research on sustainable and resilience coastal management. This conference is the third conference held by the three research centers in ITS that are the Research Center for Disaster Mitigation and Climate Change in collaboration with the Research Center for Infrastructures and Sustainable Environment and the Research Centers for Marine and Geoscience and Technology. The main themes of discussion is around sustainable and resilience coastal management. Therefore, the conference is called SRCM's conference. To some of you who have participated in previous SRCM conference, I thanks for your consistently participation. I feel proud of you to be our partners in sharing our ideas on sustainable and resilience coastal management to the world. To every freshers who have joined this conference this year, I need to disclose to you that consistently the three research centers have arranged this international conference every year. Obviously, it goes without saying that great effort went in preparing for this day because the preparation couldn't happen overnight. It requires careful inspection of every details, as even the slightest carelessness can spoil the entire effort. So let us appreciate the effort of all the committee members who are working hard day and night to make this conference successful. This conference will run till 5 p.m., trailed by the speeches, where our participants can enjoy various topics discussed. There will also be a question and answers around where all of you can ask the questions and participate in discussion with all the presenters. All the keynote speakers, presenters, and participants, this is all from me. Thank you for your being patient, and I will see you after this presentation round. Till then, enjoy the day. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Aci Pamungkas, for the insightful remarks. Moving on, we would like to invite Mr. Fadli Latul Taufani, ST, PhD, as the Director of the Directorate of the Research and Community Dedication 2022 to give an opening remark. To Mr. Fadilatuli Taufani, the time is yours.
Baik, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and greetings to all. The honorable keynote speaker, we have our distinguished guest, Dr. Andrea La Rosa, then Professor Daniel Mudiarso, and we have our college Professor Eri Kuswanto, and all the respected presenter, participant, and all my colleagues. Warm good morning to all of you, and I, as a Director of Research and Community Service of ITS, welcome every one of you to the conference, and might want to widen a note of much appreciated. Special thanks is also directed to all the keynote speakers who have already allocated their support, sharing their experiences, research, and motivation on making sustainable and resilient coastal management in this particular conference. I also thanks to all the presenter and all the participants who already took a part in this conference. The Indonesian archipelago, as one of the largest group of islands in the world, possess a abundant resource in this coastal area. Since every civilization, coastal area have been attractive settling ground for the human population, as they provide abundant marine coastal, fertile agriculture land, as well as the possibility for the trade and transportation. And of course, this promising condition has attracted settlers to move and probably led to the increase of population density as well as the development level in many coastal areas to this date. And the rising challenge in this past few decades have been regarding to the environmental pollution, of course, climate change, disaster, poverty, and so on. And Institute Teknologi 10 November, ITS, as a leading university in maritime technology and science, has a vision and mission to develop research and technology that support sustainability and resilience in the coastal area. And as a research center, as well as from the Community Service Directorate, we support vision and mission in terms of research and community services. Based on this vision and mission, the Research Center for Disaster and Climate Mitigation, in collaboration with Research Center for the Infrastructure and Sustainable Environment, as well as the Research Center for Marine and Geoscience Technology, have been collaborating to conduct the international conference on sustainable and resilient coastal management. And this conference, ladies and gentlemen, is one of the contribution of ITS for dissemination of various research that could identify and cope with the latest challenge in the coastal area. And after the successful conference last year, Alhamdulillah, again this year, we would like to show the existence and the contribution of the RPM ITS as one of the significant elements in developing research in Indonesia. Last but not least, please enjoy all the session in the conference, and we wish that further collaboration can be made after the conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Mr. Fadlilatul Taufani, for the opening remark. And now the documentation is welcome to take documentation. Documentations, the time is yours. The audience, please turn on your camera so we can take a photo. May I count it? 3, ladies and gentlemen, please turn on your camera so we can take a photo. Thank you. Thank you for your attention. And now, thus becoming the turning point of our event to officially begin. Ladies and gentlemen, we are now in the core event of the joint conference. The main activities will comprise 3 sessions, namely the first keynote speech session, followed by parallel session and ended by the second keynote speech session. In the first keynote speech session, 2 leading figures, Professor Dr. Daniel Murdiarso from IPB University and Professor Heri Kuswanto from ITS Surabaya, have prepared interesting topics to be presented shortly. To lead the presentation and discussion in the meaningful manner, we would like to invite Mr. EDAA Warma Dewanti, PhD, to moderate the first session of the keynote speech. So, without further ado, Mr. IDAA Warma Dewanti, PhD, the time moderation is yours.
Thank you, Mas Kevin. Assalamualaikum warahmatullahi wabarakatuh. I hope that all of you can hear my voice is clearly. Yeah, okay. Thank you very much again, Mas Kevin. So, good morning for all of our audience in this great event. So, this is the third international seminar, the collaboration between several of research center in ITS. And today we are very honored because Professor Daniel Murdiarso, Prof. Daniel, selamat pagi, good morning. Terima kasih. Thank you for attending and also sharing the knowledge to this participant for this morning. And also we have Professor Heri Kuswanto. Good morning.
Morning.
Prof. Heri.
Morning, Bu Warma. Nice to see
Thank you
you again.
very much. Nice to see you. Long time no see.
Yeah,
Even in the same university, but our activity is different, so it's wide. And this is a great opportunity to hear Professor Daniel and Professor Heri this morning. So before we start our session, I would like to share the curriculum vitae of each of the presenter. So Mbak Mega, could you help me to share first the curriculum vitae of Professor Daniel? Okay. Okay, thank you. So for all the participants, Professor Dr. Daniel Murdiarso is from Institut Pertanian Bogor University, and he received so many awards, and also he has an expertise as a key researcher for climate change in peatland, knowledge exchange in C4 for the past 15 years. We know that we have a big problem with the climate change and also the peatland, especially right now, our main city will be in Borneo Island, and Borneo Island also have the problem with the peatlands. Hopefully that Professor Daniel will be also talk about this one today. And also has a Nobel Peace Prize 2007 granted as one of the team member of the third and fourth IPCC assessment report author team. And Professor Daniel has so many associations as Indonesian Science Academy, Indonesian Agriculture Meteorology Association, and the International Society for Agriculture Meteorology, and also previously is maybe the head of Hydrometeorology Geomet Department of IPB University. So without further ado, Professor Daniel would like to share the PPT from your side or from our side, Professor Daniel?
I have it with me, so I will control myself.
Okay, thank you very much. So the time is yours, Professor Daniel.
Thank you. Right, thank you very much. It is my honor to be in this very prestigious event, the third international conference on coastal management. It is also my privilege to introduce my team, whom I work with, mainly my students actually. So I've been working with a large number of students. And since my audience here is also university, I would like to encourage the audience here to make sure that you have a good collaboration, especially student with your supervisor. So they are the one who can lead you to international community and also various event that now is very easy to get network. So make sure that kind of arrangement is made in your end. So what I'm going to share today is what I've been doing in the past, I don't know, 10 years maybe, with IPB University as well as C4 and ICRAF. That is an organization, International Research Center, dealing with forest and agroforestry, based here in Bogor. So I'm very privileged, and it's been very convenient to be in these institutions because they are not far away. So I can make use of.
Sorry, Professor Daniel, you might be mute your, sorry. Could you unmute the?
Is somebody muted me?
I think yes, Professor. So sorry. Yeah. Okay. Already right.
Okay. Let me know if my voice disappear. Okay. Right. So I'm with Bogor Agricultural University, IPB University, but at the same time, also with the international organization called C4 ICRAF, working in forestry and agroforestry research in Indonesia and globally. So what I'm going to share with you today is mostly the work that I've been doing with my student and trying to interact with the policy community as well. Can you see my slides?
Yes, Professor.
Am I audible? Can you hear my voice?
Yes, it's clearly.
Thank you. Right. So I'm trying to organize my talk by looking at what we know and why mangrove in this coastal ecosystem has been used to enhance the resilience of the coastal zone. So trying to look at your term of reference, I'm going to share what we know from scientific point of view about the role of mangrove and coastal ecosystem for climate change. When I say CC, is climate change mitigation and adaptation. And more than that, I would like to share, perhaps also help in the breakout session and the parallel session. How does it matter for people? So I think we should not forget the human face of our research, and also the implication for the community, for the policy community. So it is very important to communicate science properly. So doing science is one thing, but communicating science is another thing that we need to take care of. So with that, I would like to share a number of things that we need to do in the past. Sorry, in the future. I would like to show you the past experience to open up your horizon here about what we've been doing in terms of research. And I'm not sure if I can share my screen. It is not allowed. Please, host, allow me to share my slides. I'm not allowed to share it. Can I be a co-host? No.
So
Is it okay?
it's not yet okay, Professor. So please wait. Okay, already become a co-host, Professor Daniel. Yeah. Yeah.
Can you see the video?
Yes, but there is no voice. I think maybe need to share sound.
No voice.
Yes. I think need to share sound when you are sharing the video.
Okay, we'll do that. Can you hear the voice now?
Not yet, Professor, for me. I don't know other participant. Mas F. Kevin, could you hear the voice?
Not yet.
Oh, not yet. Okay.
Not
So
yet.
I think need to share the. Yeah.
No?
Yes. Okay.
Clearly
Can you?
voice, sir.
Yeah.
Can you hear it?
Yes, we can hear, Professor Daniel.
Okay, so I hope you enjoy the video flash, and that's really going to help us to understand the issues of conserving as well as restoring mangrove and coastal zone. Sorry. I should stop this actually.
It takes very specialized plants and animals to survive this bombardment of extremes. I'm a city girl at heart, so this adventure suits me perfectly. I can disappear into nature for the...
Okay, sorry about that. So with all that information you have about mangrove problems and opportunities, I just want to. Oh my God. Sorry about that. Did you see anything else?
No, Professor.
Did you hear anything else than me?
No.
Sorry about the gap tech thing. Can you see my slides now?
Not yet from my side.
Okay, you should have seen it now.
Yeah, already started.
Okay, thank you. Sorry about that. So we have so many species of mangrove. I think it's about 40 plus species, but there are a number of important and commonly used species for restoration, namely Avicennia, or we call it api-api, Rhizophora, we call it
we can see your
bako.
slide, Professor.
Sorry?
No, I think this is a feedback. Just continue, Professor.
And also Soneracia, some people, or Buguera, some people call it panchang. So there are many, many species we have, and very important to have them in the very fragile coastal zone. So when one thing about managing mangrove sustainably, they have to keep in mind about the variety of species that we have. So we should not restore coastal zone with one single species, because at the same time, if we can do that, at the same time, we can maintain the diversity, at least the species diversity of mangrove, and certainly the habitat of various flora and fauna within it. So just keep that in mind. We have been doing a lot of work, mainly to look at the carbon stock and dynamic in mangrove ecosystem. But at the same time, we're also looking at the importance of the species and also ecosystem. So there was a term called blue carbon, which was coined about 10, 15 years ago. Actually, it explained about the role of this ecosystem in keeping carbon. They are in the coastal zone or in the oceans, namely seagrass. Like this, you have to dive to look at this ecosystem. A lot of dugong and other mammals and fish and turtles around this very important species of blue carbon ecosystem. And then mangroves, certainly we have a lot of this. Indonesia has been blessed with 3-point-something million hectares of mangrove. Although half of them have already been degraded, we are still holding the majority of mangrove globally. We do not have salt marsh like this, but it is also very important. And I notice in many places in the world that mangrove is invading the salt marsh. And this is also an important component when we are trying to maintain the sustainability of coastal zone. So with that, we've been looking at the richness or the potential of mangrove in mitigating climate change. You know, if you have changing climate globally, mangrove can be proposed as a candidate to solve that problem. Why? We've been looking at these numbers in various countries, in several countries, including Indonesia, and we have about 3.1 billion ton of carbon in Indonesian mangrove. And that is quite important because if we can mitigate or avoid deforestation or degradation of mangrove, we might be able to reduce emission as much as 200 million ton a year. And that is about 30% of Indonesian emission annually. So think about 1/3 of emission reduction by mangrove if you avoid the deforestation of this important ecosystem. And not only that, when you avoid that degradation or deforestation, you also keep the habitat for various unique species in this coastal zone. The zone which experience tidal rains, pasang surut, high tide, will allow this species to survive. But in very low tide, you can see also other species will survive and make use of this important ecosystem. So in Indonesia, we have been looking at this in various situations, including the degraded one into aquaculture and also the pristine or undisturbed mangrove. You can see here the graph which indicates the stock or storage of carbon in these different stages of mangrove degradation. Comparing the very pristine one is more than 1,000 ton of carbon in a hectare. And compare with very degraded one is less than 300 ton per hectares. And most of this carbon, you can see the color here, brownish and red, are in the soil. So if you have tambak or aquaculture, there is no above ground biomass, no mangrove, very little greeny things here, but the majority of carbon is in the soil. So if you are establishing or developing any infrastructure in the coastal zone, please remember there are still a lot of carbon in it, especially in the undisturbed mangrove. So with that situation, we can propose to the government, to main stakeholder in managing, the environment, especially climate change issues. These ecosystem, mangrove, seagrass are very important ecosystem as they are keeping large amount of carbon above 1,000 ton per hectares. So if it is converted into CO2, we can multiply it by 3 or 4 or 3.5. So there's a lot of carbon in this ecosystem. So mangrove is known as, the highest ecosystem storing carbon, much higher than tropical forests. It can be 3 to 5 times higher storage. So how to tell that in the policy community? We need to communicate this understanding, these findings in a very simple message, in a very lay people kind of language, by illustrating the importance of mangrove. If you can, avoid and preserve mangrove, it is very likely that we can reduce emission from fossil fuel, or cancel the emission or offset the emission as much as 40 million cars a year. So if you find it's difficult to communicate about carbon in mangrove ecosystem, tell the policy community this is the equivalent of keeping mangrove in the soil of mangrove ecosystem. 40 million cars a year can be offset by mangrove, by having mangrove and not cutting them. So the issue has been brought to global community, especially with the climate change convention. So in the Paris Agreement, there are a number of means to mitigate climate change, including REDD+, NAMA, NDC, and also very importantly, the adaptation, because mangrove offer a lot of facilities, a lot of services to adapt with the changing climate, especially the rising of sea level because of the global warming, because of the expansion of the volume of the seawater and the melting of the polars, the glacier in the poles. So it is very important to send the message across that yes, blue carbon ecosystem, mangrove, seagrass, and salt marsh can do something about it. So with that message, you can also go on and on and on to various global agenda like Sustainable Development Goal, SDG. If you take mangrove, you can relate everything on the role of mangrove to SDG, at least 9 SDGs here, 9 goals. Number 1, dealing with poverty, because mangrove can provide, livelihood. It can provide, you can see in the video, a good meal for children, especially those who are malnourished. Fish has a lot of nutrition, which is useful for growing kids. So it's very important for health, clean water, sanitation, climate change, certainly, and other issues. So one single ecosystem can serve and provide a lot of services to human being. And from biodiversity point of view, CBD, Convention on Biological Diversity, they have target which was set in Aichi in Japan. Again, blue carbon and mangrove can hit 3 targets. Target number 6, dealing with fish and invertebrate stock. Coral bleaching issue can be managed by mangrove and other blue carbon ecosystem, and certainly restoration of carbon stock in the coastal zone. So blue carbon mangrove can be a great candidate for improving or enhancing coastal resilience. So looking at the theme of your conference, I brought this into your discussion later in the parallel session. Let's think about the human face of mangrove. What is the imperative of having mangrove for human capital, human being, and human well-being? So there is a commission led by former UN General Secretary Ban Ki-moon called Global Commission on Adaptation, who predict that if you invest 1.8 trillion for adaptation to restore coastal zone, As you know, this last year was the starting year of the UN Decade of Ecosystem Restoration. So Ban Ki-moon Committee or Commission predict that if you invest less than 2 trillion, you will produce net benefit of 7 trillion. So you will quadruple your benefits from what you've been investing towards the end of the decade. So it is very important to look at that from a human perspective. Certainly, people will benefit from the economic perspective of this restoration and conservation of coastal zone ecosystem. And at the same time, also, services like flood avoidance and also fish production. So these are some numbers that are related to what we can have if we have mangrove. Other ecosystem services that can be provided by mangrove ecosystem is the economic value, which is the highest among blue carbon ecosystem. Mangrove produce a lot of fish because it is the place for the fish to hatch. So the juvenile, the babies of the fish will be hiding in mangrove before they are attacked by predator. So the sustainability of fish production offshore will be very much dependent on the presence of mangrove. And that's, economically speaking, is very high benefits to have mangrove intact. Another service that is provided is dealing with the increase of sea level. I and my team have been working to look at various numbers in terms of land building capacity. So mangrove trappings sediment so that they can build land faster than sea level rise. So that's very important. If you keep mangrove intact, it's very unlikely that the land behind mangrove will be flooded or will be submerged by sea level rise, which is the implication of the cause of the impacts of warming climate of our planet. The local community now is very anxious and also enthusiastic to use mangrove ecosystem for local ecotourism. I've seen in a number of places that if I have time, we can show you how local tourism flourishing now in many places in Indonesia and elsewhere in the globe, because the ecosystem provide habitat for this unique, wildlife, including proboscis monkey and also spoonbill waterbirds. They can stay there because they can find food. But if you do not have mangrove, they will not be able to stop there while they are migrating. Certainly, fish and shellfish production will be improved if you have nutrition enough for them by keeping mangrove intact or reintroduced when it is degraded. So aquaculture will be better off with mangrove rather than without mangrove. So that's the message from keeping mangrove intact in the ecosystem. How to communicate that with the policy community? We, as researcher, scientific community, should be able to translate that in a simple language, in a common kind of interest rather than just science, by developing this kind of document called policy brief and reveal the potential of mangrove for improving the economic aspect and also sustaining economic growth at the same time. You need to organize a webinar. Now it's very easy to have people joining and make sure you know who are the audience so that the message can be packaged in such a way that the message will go across to the audience that you have in very easily organized webinar nowadays. In a higher level, we also introduced the importance of mangrove in the nationally determined contribution. Indonesia has been submitting its second NDC, or enhanced NDC, especially the role of mangrove for climate change adaptation, in addition to climate change mitigation, as it contains a lot of carbon in it. In adaptation, it's very rarely mentioned how important it is to have mangrove intact to avoid flooding, etc. Even in higher level, we've been contributing to the IPCC, Intergovernmental Panel for Climate Change, with numbers, which is used globally to estimate emission for national reporting, not necessarily Indonesia. It can be adopted by many other countries hosting mangrove in their coastal zone. So scientific community has the very role in influencing the decision making, as well as in the global community arena. So the take-home message here is that hard science is badly needed. We use to work in the field, so we still keep on doing that, because information is still lacking. We know a lot, but not everything. We need to go further in understanding the role of this coastal zone ecosystem in various aspects of humanity. And make sure we communicate that. It's not just for publication. Improve your age index or citation, but improve the policy making processes. And also the humanity aspect here is very important, because only with numbers, only with evidence, policy can rely on. And you cannot just assume things, but make sure you provide number, even if it is less certain, even if it is not exactly, but whatever number, scientific number is needed nowadays. So make sure that mitigation and adaptation of climate change is addressed in your research, and we try very hard not to look at from mitigation only, but also adaptation, because the resilience of coastal zone in adapting with the changing climate is very, very hard without involvement of these stakeholders, especially government. And if you have the chance to involve a local community, that's even better. So that's all I would like to share with you. If I have 3 minutes, I will show another video if I have no problem with the technical glitches. But if not, that's all. Thank you very much.
Thank you, but it's okay, Professor Daniel. I think it's very interesting to show your video, because previously it's very interesting also, and hopefully that it can be.
Let me try, but if it doesn't work, I apologize for that glitches. Let me try to show that. I have to make sure I have shared the sound and click the video. That's what my wife told me. Can you see the video?
Yes, so we can.
And I'll play it. This is in Central Java.
Oh.
Can you hear?
Yes, we can hear. Yeah.
Dulu jalannya di sini, dan orang lalu lalang berkendaraan motor bisa di jalan ini.
sekarang mereka harus tinggikan hanya untuk jalan kaki setinggi kira-kira 100 sampai 120 cm, dan motornya diparkir jauh di depan sana karena sudah tidak mungkin lagi membawa motor ke rumahnya. Jadi laju penggenangannya memang luar biasa besar.
Ini jadi adalah contoh rumah yang belum ditinggikan tapi sudah sejajar dengan air laut. Bisa dilihat ini perairannya sama dengan lantai rumahnya sendiri. Jadi ini ada urukan itu seperti lahan yang sudah ditinggikan. Jadi rumahnya masih belum ditinggikan, tapi untuk jalannya ini udah bisa ditinggikan.
Desa ini luasnya sekitar 500 hektar, 1/5 diantaranya sudah terendam seperti ini. Jadi Timbul Sloko adalah salah satu desa yang mengalami, orang di sini mengatakan rob atau banjir dari laut. Kemungkinan disebabkan karena naiknya permukaan laut, tapi ada juga kemungkinan lain, yaitu tanahnya mengalami penurunan atau subsidensi. Yang mana yang benar kita mau coba ukur, kita mau coba buktikan bahwa hal-hal itu terjadi atau tidak. Misalnya subsidensi berapa sentimeter per tahun, kalau itu terjadi lambat berapa lama akhirnya desa-desa seperti ini akan terendam air. Kita akan mengapresiasi betapa luasnya penggenangan ini. Kalau kita lihat dari udara, banyak rumah sudah mulai terendam. Jadi mereka mengungsi ke tempat lain.
Riset yang dikerjakan ialah mengidentifikasi Coastal Vulnerability Index ataupun kerentanan pesisir di wilayah Demak, dan tentunya di 3 lokasi nantinya, ada Banten dan juga Banyuwangi, 2 yang lainnya.
Ada 3 hal yang saya lakukan di sini terkait dengan penelitian. Yang pertama adalah pemasangan arset yang akan dilanjutkan 3 bulan kemudian untuk pengukuran arset. Yang kedua adalah pengambilan data lapangan untuk biomasa pohon, sapling, dan juga dilanjutkan dengan pengambilan sampel tanah untuk carbon stock di dalam tanah. Aktivitas yang ketiga dilakukan adalah pengambilan sampel tanah untuk analisis sedimentasi.
Ini adalah APO, satu struktur alat pemecah ombak yang terbuat dari konkrit, semen, beton, kira-kira 100 meter panjangnya, disambung lagi, dibangun sekitar 10 tahun yang lalu. Tapi ini sifatnya sementara, karena dengan pemecah ombak ini, mangrove yang tumbuh di belakangnya sempat bertahan dan tumbuh setinggi ini, sehingga nantinya ketika APO ini rusak, mangrove inilah yang menggantikan. Di sana ada hibrid atau campuran antara bahan alam yang berfungsi seperti APO juga, tetapi dia lebih permeable sehingga arus bisa masuk, dan ketika kembali mengendapkan lumpur, sehingga suatu saat di belakang dari barrier atau penghalang ini bisa ditumbuhi mangrove juga secara alami.
kegiatan penelitian yang saat ini sedang kami lakukan akan menilai kontribusi hutan bakau terhadap ketahanan pangan keluarga, penghasilan keluarga, serta asupan, kecukupan zat gizi makro dan mikro, keberagaman pangan beberapa kelompok makanan penting pada ibu dan anak usia 2-12 tahun di wilayah sekitar mangrove.
Thank you very much. So I have to make sure I stop everything. Thank you.
Thank you very much, Professor Daniel. It's a very interesting talk in this morning. So I think a lot of participants already would like to asking. I think Professor Ketut already raised hand, and some of the participants already raised hand also to asking. But we are stopped for a while for Professor Daniel because we would like to invite the second of the keynote speaker today. So please wait for a few minutes because Professor Harry is also talk a lot about the climate change after this. So after that, we will have the question and answer and discussion. So allow me to invite Professor Harry Kuswanto. Professor Harry.
Yeah, good morning.
Yeah, good morning. So could we share, Mbak Mega, the CV of Professor Harry before we start? Prof. Ikab and Ibu Noni, maybe later on we can have the question and answer after Professor Harry. Yeah. Okay. Okay. So this is the CV for Professor Dr. Rerpo Harry Kuswanto, MSc. So the expertise, awards, and education. Professor Harry is the youngest professor in our university in Institute Technology School November. And the expertise is statistical computing, time series forecasting, econometrics, and then extreme weather and climate. And then the current publication, they have so many publication in recent years, and then already published also in some of the Q1 journal and Q2 journal. So Professor Harry, without further ado, so the time is yours. And then we will be share your presentation from here, right, Professor Harry?
Let me share from my side, please.
Okay, so please.
Okay, thank you very much to Warma. And yeah, very interesting talk from Professor Daniel, very insightful. Thank you very much, Prof. So, okay, let me share my slide. Okay, so what I'm going to talk today is a little bit different with what Professor Daniel already presented. The topic of my presentation will be about solar radiation management, and we try to look how will be the impact of deployment of the solar radiation management to Indonesian climate. Yeah, I start with this IPCC pathways about future emission scenarios. So I hope all of you are familiar with this one. So we have here RCP 8.5, which is a business as usual, and we have also here RCP 2.6, which is the condition that expected to happen. So basically, this RCP scenario describes the alternative trajectory for carbon dioxide emission and the resulting atmospheric concentration from 2000 to 2100. And yeah, this is about the progress in climate mitigation. So we can see here that, of course, in order to reach this pathway, this is not an easy task. There are a lot of effort that, and commitment that have been done by all of the countries of the world. And yeah, but the question right now is that, is it really on the track that we will be able to achieve this pathway in the situation that the temperature change will be below 1.5 degrees Celsius? I just read from the website of UN, and they say that no, we are not on the right track right now, because some countries, they already signed the commitment, but in fact, in the reality, they're progressing very low. So in this situation, of course, there is much more something that need to do. And in this presentation, I would like to introduce you a little bit about how about the climate intervention, or I call it here CI. And in fact, also, if we revert to this graph, so we can see that by 2021, the temperature increase has already exceed 1 degree Celsius here. And this is the global average temperature from 1850 to 2021. And we can see here the consistent trend that the global temperature will increase either in the global here means that this is the temperature in the land and ocean. But here I tried to pick the trend of the global temperature change in the land, and we can also see that the increase here is even higher than combined with the ocean. And yeah, talking about the climate intervention, so it's basically about how we manipulate the planet. In this case, the sunrise, and there are two very popular climate interventions that are become in the conversation of the global world, which are called as carbon dioxide removal or CDR and solar radiation modification. And yeah, this is just to give you a bit overview about what is CDR. CDR is basically the removal and long-term sequestration of CO2 from the atmosphere in order to reduce global warming. And SRM. So SRM here is the solar radiation management. So I will show later some kinds of the technology that belong to SRM. Of course, yeah, right now it still become very controversial idea, controversial technology, whether it can be really deployed or not, considering the impact of deployment of the SRM over the world. So yeah, the discussion is already there. So if you can see here, the publication from the National Academy, they try already explain about what the carbon dioxide removal and how can we do the intervention to the climate by reflecting sunlight to cool the earth. So my presentation today will focus on solar radiation management instead of carbon dioxide removal. Yeah, this is one point that need to be pointed out, that SRM is not replacing the current scenario. So this is just a supplement too, which means that, okay, the current scenario can still be done, but then in order to speed up the achievement of reducing the global temperature, we might need something. In this case, the technology that is offered is the stratospheric aerosol injection. And again, I will show you later some kinds of SRM that has already researched by many researchers in the world. So this is the point, because when we talk about solar radiation management, people might think that, oh, this is something new. It will replace the current scenario. But in fact, this is not, because the way of doing the simulation about solar radiation management, we keep following the pathway that already done so far. So in this case, we try to do something which try to bring the situation into the target of the temperature change, which is below 1.5 by 2050. And yeah, so the discussion about climate intervention, especially the solar radiation management, is already there. So starting from 2015, there is a formal report from National Academy US. They try to introduce the concept, or the concept of the reflecting sunlight to cool the planet. And then 2021, they already also published another report about more detail about reflecting the sunlight. And yeah, this is the three kind of solar radiation management that is going on the global debate right now. So of course the idea is the same. We try to attempt or to moderate the warming by increasing the amount of sunlight that the atmosphere reflect back to the space. So what I'm going to discuss today is about stratospheric aerosol injection, SAI. So you can see here, how does it work? So in the stratospheric level, we will try to inject, in this case, is a sulfur and other materials split out here, and then we expect by this SRM, it is expected that the sunlight, part of the sunlight will be reflected back to the atmosphere, and some will be absorbed in the earth, which means that we try to make a layer by which not all the sun will go into the earth. And yeah, this is the idea of marine cloud brightening and also cirrus cloud. But so far, what I understand is that the discussion about these two SRM technology is not as much as the SAI. So you can see here that this is one of the effort that has been done by the Harvard University team. They tried to develop the balloon that will transport the material to the atmosphere for the injection. And yeah, the idea of this lab is that we noticed that the discussion or the research about SRM until today are mostly conducted in the global north. Means that yeah, the developed country do this, but we are in the global south. We are developing countries. Of course, we cannot just keep silent with this idea, right? Because in terms of the climate change impact, we are in the developing countries is one of the most vulnerable countries toward the impact of the climate change, which means that later, if the SRM here is really deployed, what will happen with us in the global south here? So if you try to look the application, for example, or the idea of SRM, of course, the discussion is much more in the developed country like US, China, UK, and so on. But in global south, the discussion is still very low. Means that we still need to introduce a lot this to the policymaker and so on. But we would like to point out that by deployment of the SRM, of course, the impact will be also goes to the global south for to the developing countries. And yeah, fortunately, there are already some research has been conducted to investigate the impact of the solar radiation management to developing countries. So it's basically or mainly funded by the Degrees Initiative, which is based in UK. And their mission is that they want to put the developing countries at the center of the SRM conversation, considering the fact that we play a very vital role in this case, either getting the impact or we can also do something dealing with this one. So there are some references that I put here. Later, when you have time, you can just look at this publication to see or to understand a little bit more about what will be the impact of solar radiation management. So here, sometimes we call it as a solar geoengineering. Basically, both of them refers to the same technique. And yeah, this is the very recent publication from Carlson et al. To 2022. They try to look the impact of the solar radiation management against the distribution of the malaria risk in developing countries. And some people or some researchers are really focused on hydrological things. This is also what my team right now doing together with our team from Malaysia and Vietnam. We try to look at the impact of the solar radiation management deployment to the extreme hydrology in Indonesia, Malaysia, and Vietnam. And another research try to look at the impact to the storm track changes. So it's done by the team from Middle East and from Middle East, but they look at the case study is in the Middle East and North Africa. Now, what about Indonesia? So, yeah, the thing that I would like to present right now is based on our recent publication in the International Journal of Climatology. So what we do is that we try to look the impact of solar geoengineering on temperature over the Indonesian maritime continent. So later when you have time, then you could read in more detail to understand about the content of the paper. So it's basically joint research with our colleagues from US and also from China and from BMKG and also two of my research assistants. And this research was funded by Decimal Funds, which stand for Developing Country Impact Modeling Analysis for SRM, in conjunction with the World Academy of Science in Italy. And yeah, why temperature? Of course, this is just the preliminary research, means that we try to do the research starting from something which is very simple, and later on we try to dig some ideas about what can we do here, because doing this research about the impact of solar geoengineering, we will need very comprehensive data set, observation data set, and so on. So yeah, this is just the reason why we focusing our research in temperature for the first time, because we realized that yeah, as I already shown in the previous slide, that the temperature is getting increased and increased, right? And the first thing that we would like to see is what will happen with the temperature in Indonesia. Yeah, we will see on some temperature and the derivative indices after this. And if you this is just taken from the Tropical Peatland Society project in 2019. And if we can see here that Indonesia is very vulnerable to the fire, right? So we later also will try to see what will happen with this over this area, over this region, if the SRM is deployed. And yeah, this is just to show you about the trend of extreme temperature in Indonesia. So based on the research from Supari et al., they found that the annual means of the daily maximum temperature and minimum temperature has increased significantly by 0.18 and 0.3 per decade. And yeah, of course, the situation will be increased and increased if the scenario doesn't really work well in this case. And another thing is from the IPCC fifth assessment report, that the tropical countries such as Indonesia will experience long-term warming with the projected temperature change to mid-century exceeding 2.5 degrees Celsius. So we can imagine that this is very scary situation, right? So increasing by 2.5 is really significant in this case. And yeah, why this study is considered to be important? Because again, most of the current research about solar radiation management impact has been done in a global or regional scale. So we would like to see in a more local impact. So that's why by Decimals they try to fund the project which really focus on the local impacts in several developing countries. And then, yeah, we have to admit that this is the first investigation of SAI impact on Indonesia, particularly the ability of SAI to offset temperature change over the Indonesian maritime continent due to the climate change. So another thing that we would like to point out also that by doing this research, it doesn't mean that we stand, we pro or support the idea of solar radiation management. In fact, this is still very controversial idea, right? So by doing this research, we will try to provide a scientific evidence about the SAI impact. So if good, then we will say good. If not, then we will say no. Because later when the policymakers ask to give their voice about whether they will deploy or not, or they will support or not the idea of SAI, then the result of the research can be one of the reference for the policymakers in the global debate about the deployment of SAI. And yeah, of course, we still need to do many research about this one. And this is just to give you a bit idea about what we do. So we focus our research by looking at the impact over the Indonesian maritime continent defined by this location here. And yeah, we still focus on daily surface air temperature and relative humidity. There are some statistical works that we do before we analyze our data set, something like we do the downscaling process, we do the pre-processing process about the data set and so on. But I skip this information, the result of the downscaling in this situation, because it's very technical. So this is what we research about the SAI. So basically, there is a geomip experiment. So they do the simulation with several scenarios. So they have G1, G4, G2, G3, and G4. And we're interested here in G4. G4 means that there is the SO2 injection here, but following the pathway of RCP 4.5 here. So there are the detail of how, the basic information about how the G4 experiment is done. The important thing also here that the simulation will run until 2070, but after that it will be terminated. But again, some researchers are interested to see also what will happen. So if the injection goes along the year until 2070 and suddenly it stops, what will happen with our climate here? So we'll try to look at this also in this research. So this is a data set that we use. So basically we examine 3 sources of data set from BNUSM from China, and then MIROC ASM and MIROC CHEM ASM. But we skip the result from this MIROC CHEM ASM because the result is rather similar with MIROC ASM. And we define the historical period here as 1950 to 2005, and the projection period is 2020 to 2069. And this is actually the period of after the termination of the SAI. And the original variables, climate variables that we analyze here is surface air temperature and relative humidity, and we will get some derivative variables afterwards. So you can see here that about the resolution, about the scale of the data set, and so on. Yeah, this is about the downscaling. I don't want to talk more about this one, but to give you some rough idea that because the resolution of the data set is so big, it's very low, the resolution is very low, then we cannot just simply take the data set and then analyze it. So we need to do some statistical analysis. In this case, is doing bias correction and downscaling to our data set. And yeah, we choose the best one among these three methods, and we use that as the data that to be analyzed for investigating the impact. So this is the impact of SAI to the future temperature change. So here, what I put here is the left figure. This is the difference between G4 and RCP 4.5. And this is the difference between G4 with historical periods. Means in this case, we talk about the anomaly, but in this case, we talk about the, I will say the effectiveness of the G4 scenario. So if we look at this one, there's three simulation give a consistent result that the difference between G4 and RCP 4.5 are mostly negative, which means that the level of the increasing temperature resulted by deployment of the SAI, in this case is G4, will be higher than RCP 4.5. So in a simple word, we will say that, okay, this is effective enough to reduce the temperature change. And here, if you see the anomaly also, the G4 will be able to keep the temperature change no more than 2 degrees Celsius by 2080. But before 2070, the temperature will be able to be the temperature change will be able to be kept below 1.5 degrees Celsius. And yeah, this is the special pattern about the difference between G4 and RCP 4.5 and the anomaly. So we are interested in this anomaly. So as already shown in the picture of the beginning of this presentation, that we identified that this area are the fire spots, and this area are the drought-prone areas. So it will be interesting to see what will happen if the SRM is deployed with this region, because we never know whether it will give positive or negative impact. Positive means that whether the temperature in this area will be keep increasing by the deployment of SRM, or temperature will be lower, which means that the situation will be getting better in this case. So here you can see that this is the anomaly. So the increasing so in the Papua and Nusa Tenggara Barat, for example, so the temperature will decrease instead of increase. So compared to the historical periods, so this is a good sign, of course. But for this area in Sumatra and Kalimantan, we can see here that the temperature is will be increased. Yeah, this is just following the general pattern, but this research shows that the temperature will increase in these two regions, which means that the situation might getting worse by the deployment of SRM. And yeah, the steeping, this is the note that steeping points here indicate that the difference or changes are not significant at 5% level. And this is the impact of SAI on extreme temperature. I think we see this similar pattern with the mean temperature here. And I will go ahead with this. Yeah, this is the extreme temperature increase in the 4 area that we point out here. So again, there is a consistency between the mean temperature and also with the between mean temperature and the extreme temperature here. So here we can see that in the future, by the deployment of SRM, that the extreme temperature in this area will increase and significantly, because there is no dot here. And with this area, the extreme temperature will be decreasing significantly as well. And yeah, this is about the moderation and exacerbation test, which try to give information about whether the climate change will moderate or exacerbate the situation in this spatial area. So what we can say here that yeah, from this mean temperature, so most of the areas here are will be moderated by the climate change. So it indicates by this is the negative, but this is significant because there is no steepening point here. But by the extreme temperature here, we can see here that the temperature will getting increased, which indicate also that it will be exacerbated. So you can see here the red area. They are the area that the climate change will exacerbated by the deployment of the SRM. And we try to see also the impact of SAI to the WSDI. WSDI here is defined as the long of the streak of 6 or more days, defined by this one. And yeah, we can expect a good result from this one, as we can see here that from the simulation of the PNUSM, the the length of the days, the WSDI is greater or longer for RCP 4.5 compared to G4. But again, after 69, the level are the same, means that the situation will rebound to the previous level. So this is what will happen after SRM will be terminated. However, by the deployment, we will be able to expect that it will be effective to decrease the length of the WSDI. And yeah, this is the WBT. So basically, this is derivative of using, the calculation is using relative humidity and also the temperature. But we focus here on the WBT greater than 27 degrees Celsius, which relate to the situation that this WBT greater than 27 degrees Celsius might danger the health of the human, and it might create the heat stress, especially for someone who do the physical activity outside. And yeah, from the research of Spark and Cloudfield, they also define that the threshold 27 is the threshold where this is an emergency condition for the livestock. So we can see here that, of course, the WBT greater than 27 degrees Celsius currently is not that much, but in the future we can see that by applying only RCP 4.5, the number of the days where the WBT greater than 27 degrees Celsius will be significantly higher, and it can be significantly reduced by the deployment of SRM. So the difference between this one and this one is just this is based on PNU simulation, and this one is based on MyRFSM. Again, why I'm not really going into detail to the result of MyRFSM, because the result is mostly consistent among these three simulation. And this is spatial pattern. So again, if we look at the anomaly here, there is not much change. But one important thing is that by the deployment of the SRM, the WBT greater than 27 degrees Celsius will be significant over the sea, but not over the land, which means also that, of course, it will get influence to some areas, to these coastal areas, and then how it will impact the fisheries field and so on. So this is something that might need to be researched out. But basically, what we find so far is that there will be a significant reduction of the WBT over sea compared to over land by deployment of the SRM. In this case, is G4. Yeah, this is the end of my presentation. Just to summarize and give an insight about the future work that we can do. So yeah, we find out that SAI could reduce some of the negative impacts of climate change induced by temperature, and then SAI could be effective to reducing the risk of drought in highly vulnerable areas in Indonesia, which is associated with extreme temperatures. But we also see another fact that it might dangerous or give negative impact to other area, which is vulnerable to the fires. And then, yeah, the extreme temperature over the fire spot will be projected to be higher than in the historical periods. And there are a lot of uncertainty that we found during the analytical stage of this research. Yeah, we can see here that, of course, the uncertainty can be induced by the modeling process itself, the experiments. Like I say that the result among these three models, among these three experiments are similar, but in some cases they are quite different. So in this situation, we still have no idea what should be revert, which one should be revert. And yeah, I still remember also that during our last conference in US a couple of months ago, there are a discussion about the source of uncertainty. And of course, this is the first study, and there are still a lot of things need to be investigated, especially about the impact of SRM deployment to other fields, other like.
Sekarang pukul 10.19.
Hello. Can you hear me?
Yeah. Noise.
Yeah. Yeah. So there are still a lot of things need to be done, especially dealing with the impact of the SRM. So when we try to talk about SRM to someone here in Indonesia or in most of the developing countries, what comes in their mind is that, oh, really? Can it work? And what will be the impact to our health? And they always think about the negative impact, like what will happen to the ecosystem, what will happen to the social life. And yeah, it comes to the interest. This is good because the debate is there, and again, we plan to do that in the future. Yeah, these are some topics that can be researched out in the futures regarding the impact of solar radiation management. Yeah, I think that's all from me. Thank you very much, and back to the moderator.
Thank you very much, Professor Harry. It's a very interesting talk. We have two speakers that is very interesting talk today. We have Professor Daniel and also Professor Harry. If I can resume a little bit about what is already talking by Professor Daniel previously is about the mangrove and then the impact on our life especially, and how about the communication to the science, communication of the science to the policy, and also take home message that is very important from Professor Daniel. And Professor Harry talk about the a very advanced, I think, because this is the technology that about the solar radiation modification, and then how they can have a climate intervention, and also how about the impact in Indonesia. I also have some question to Professor Daniel and Professor Harry later on, because we already have so many participants that would like to have the discussion to both of the keynote speaker. I know from here. So please, for the organizing committee that can help me. First, we have Mrs. Loela S. Digamon from Philippines, I think. Yeah, could you ask directly to Professor Daniel or Professor Harry? Could you unmute your microphone? Mrs. Luella, I think you are in the meeting. Yeah.
Good morning, Miss Warma. Good morning from Surigao City, Philippines. Thank you so much, Professor Dr. Daniel, for a very substantial talk. Actually, I already posted my question in the chat box, but then since I was asked to raise my question live, so actually I appreciated the talk because we did also a research about mangroves here in Surigao City. And it is really true, and it has been proven through our research that mangrove really did a potential role in carbon sequestration. So I would just like to know what are the community extension services or projects that you have extended, because perhaps we can benchmark on this, because right now we're doing our community extension project based on our assessment on the mangrove ecosystem here in the Philippines, in our locality. So I would just like to know what are your projects or your community extension services so that we can benchmark on it, or we can should I say we can copy or we can imitate the extension services that you have also, but it would be contextualized, of course, here in Surigao City, Philippines. Thank you so much, Prof. Daniel, and thank you so much, Ms. Warma.
Yeah, thank you, Ibu Loela. I think it's a very interesting comment and also question, Professor Daniel. So, Professor, could you comment to the Ibu Loela first?
Okay, I will. And if I may, I will have to stop before 11 because I have a class at 11. So please allow me to escape after some time. Okay, Loela, it's great to hear about your experience working in Surigao City in the Philippines. I've been wandering around in the Philippines working with colleagues in Los Baños and places like Laguna. It's interesting to hear more from you about the community perspective of the importance of mangrove. Yes, I agree that one thing that happens and work in one place cannot be copied immediately to other places. It has to be tailored towards the local agenda. And I underline this phrase, local agenda, is very important. Even carbon is not always local agenda. It's not always a community agenda. So bear in mind that they are doing a lot of things to sustain their livelihood, and they might not know that their livelihood is very much dependent on the presence of mangrove. So what I would like to suggest as an approach to work with community is that there are many other ecosystem services that they can directly enjoy without waiting too long with this all negotiation, carbon cowboys and those kind of stuff. It is very confusing. So carbon can be even the co-benefit rather than the other benefits that the community have already been enjoying so far. So make sure you are mindful about the local agenda, and restoration and also conservation is another aspect that we can introduce working with other stakeholders who really is having in their agenda about this activities, conservation and restoration. So carbon is only one of the numbers and benefits that they can provide when you conserve or restore mangrove, but that's not everything. National government can be very interested in doing that at national level, nationwide, but not necessarily the case for local community. So that's my response. Thank you, Warma.
Yeah, thank you, Professor Daniel. Hopefully that maybe in the future can have the collaboration with the Philippines, especially because they have similar problem with the Philippines in Indonesia. Thank you, Professor Daniel. And we already have Ibu Noni Sumarsi. So for all of the participants, if you would like to ask and have the discussion, you can raise your hand or you can write in the chat box. It's okay to use Bahasa and then we will translate in English. So please, Ibu Noni.
Thank you, Mr. Mama. My question for Mr. Professor Daniel. As we know, Professor, the issue of
Noni, could
yes?
you a bit clearly because a little bit noise in your place, I think.
Okay. Hello?
Okay.
Please.
So
Clearly?
yeah.
Okay, thank you. Okay, my question for Professor Daniel. As we know, Professor, the issue of carbon dioxide is becoming public issue, and one of issue we discussed in the conference of parties of COP 20 in Egypt, Sharm el while another while the academic also calculate how the potential from mangrove to become blue carbon. And my question is, according to Professor, how big is the optimal mangrove ecosystem to reduce carbon dioxide emission regionally and globally? Thank you.
Yeah. I think I'm a little bit catch up what Ibu Noni asking Professor Daniel. This is about how the mangrove can be one of the tools for captures of the carbon globally and locally. I think this is the question, I think.
Okay. Yeah. Okay, I think it's very clear and interesting questions. Let me clarify a number of things which is often misunderstood in general public. People think that mangrove is growing so well. When they grow, they sequester or capture a lot of carbon more than anything else. That is not true. The truth is that while they are growing, they are also depositing litter. They are also depositing degraded dead fine root very quickly. Which we call it the primary production is very high with high turnover. Okay, so mangrove is like any other species, like many other terrestrial forests, but the way it is depositing organic material is different. So once it is deposited there, it is submerged and not very easily oxidized. They are decomposed. Sometimes it's not fully decomposed as organic material below the ground. That's why so much carbon is in the soil. The tree is very tiny. As in my background here is quite a healthy rhizophora here. That's very big. But in even small, or we call it dwarf mangrove, like Avicennia, you still have a lot of carbon in the soil because of the high primary production and then high turnover in terms of leaf deposited in the soil, and also the fine root, which is decomposed, and then they replenish with a new one very quickly. They don't grow that fast, but replacing the falling leaves and replacing the decomposed fine roots. That's why soil carbon is so rich. Okay, so let me clarify that, because very often people think that, okay, we plant mangrove tomorrow, and then the following day you will sequester so much carbon. No way. They might be pulled out by people. And they don't sequester anything, So let me demystify this kind of misunderstanding. Because a lot of people think that it is a magic tree. No, it can live it can grow in tidal range, high and low range of sea level. but it's not like the terrestrial forest, but in terms of growth, in terms of rate in sequestering carbon dioxide in the atmosphere is almost the same. Thank you.
Thank you very
I hope that helps.
Thank you, Mr. Daniel. We have one participant again that raised hand from UTM. Bapak Haris Septian.
Is my voice heard?
Yeah. Yeah, Pak Haris, could you?
Okay. Thank you, Ms. Warma. Thank you to Professor Daniel and Professor Harry for the extremely interesting presentation of the material. Let me ask the question for the both of Professor Daniel and Professor Harry. Considering it is now the end of the year, are there any specific issues in coastal management which is variable from now on that will be the biggest threat among marine researchers in the coming year, especially in Indonesia?
Yeah, I think it's thank you, Pak Hari. So this is a question for Prof. Harry and also Prof. Daniel. Maybe I give the time for Professor Harry first. Pak Hari is asking about the special issue that might be is very important to take a look in the next future, especially in 2023, about the coastal management in Indonesia.
Okay, thank you. So I have to be honest that this is beyond the expertise that I do so far. So I will let Professor Daniel to answer this question. I'm sorry. Thank you. Because this is very specific about coastal management, right? Yeah.
Okay. Yeah. Okay. So Professor Daniel, do you have any comment for this one, Professor? In the next 2003, in the futures, what will be the big issue for the coastal management in our area, especially?
Well, Paris, as you know, the government of Indonesia and probably also many others in the region are trying to restore the degraded mangrove to improve the quality and resilience of the coastal zones. But we can almost expect that usually this is a national program and top-down and very little involving local community. So the danger or threat of doing it in such a way, top-down, big scale, is that if you make a mistake, you will expand your mistake very quickly. So my take is that if you have such a program, it has to be tailored towards the local need. So, for example, if you want to restore mangrove, as you know, government of Indonesia, in the video, we show that we will be restoring 600,000 hectares of mangrove. That's not a small amount. You know, we do not have experience in restoring mangrove even 10,000 hectares successfully, very little rate of success. So how can you do that with such a challenge? 600,000 in 4 years until 2024, even less than 4 years now. So the danger or the threat here is the failure, because policy always the case, they have a top-down policy and it has to be implemented everywhere with the same format. And I keep warning the policymaker, my colleagues who are there in the ministry and the practitioner, look, we have to be careful here. Now let's be honest about our capacity in restoring mangrove. And this is not a convenient thing to say, you know, but the truth is that the rate is very low. So we have to be careful in prioritizing which ecosystem, what kind of coastal zone need that kind of technique, and what about the other type of coastal zone, geomorphic setting will require. They will be having different requirement in terms of the species to introduce, the way it is planted. And sometimes, in many cases, you do not need to plant anything. Just improve or restore the hydrology, the mixture of saline and fresh water. Seawater and fresh water from the river is very important ingredient for mangrove to grow. But if you don't provide that kind of environment, just plant it here and there, it will die, because they don't have such a circulation and mixture of good stuff for mangrove to survive. And I've seen a number of cases in many other countries. Improving hydrology will help the species, the pioneer species, to colonize, the degraded mangrove without any intervention, just improving and restoring the hydrology. So I hope I can send the message across, especially to our young fellows here. And I'm old enough to continue doing things, but I'm happy to see, next generation are very eager to understand and to know more about mangrove. Thank you.
Thank you, Professor Daniel. It's a very big message for us, especially for the activity in the future, because the future is our turn. So we also have Ibu Nova. Ibu Nova.
Yes.
Ibu Nova from ITS,
I
from
Ibu
Nova.
Okay, thank you.
Yeah.
Okay, thank you, Warma. Hello, Pak Daniel Mudiarso. I'm Nova Maulidina from Biology ITS. I'm very happy to see you today, although in online. Actually, I already read your paper since 2014, since I'm in magister in Indonesia University. Okay. Yeah. I'm very interesting about the mangrove ecosystem that very have a main control in our ecosystem. And what do you think about carbon trade? And besides that, we know that mangrove have a very high potential to our life, but we know that some development countries, some developing countries should be keep their ecosystem in good condition, but in developed country like in Europe, like in US, they still have produce maybe carbon dioxide like that. And what do you think about this carbon trade? Is it really give a good benefit to developing country? And beside that, also in developing country, in mangrove area also, we need to develop to build some housing, or maybe some eco-wisata or something like that. And it's very contradictory program maybe. So actually, what's your opinion? What should we do as an individual maybe, or maybe as a community, or maybe as a government? Because sometimes if we have a good program to our community, to our ecosystem, but sometimes it have to face with the situation that the company have a relation with the government, so the program it could be the program cannot doing well. So please, what your opinion about trade carbon, and then what we have to do as an individual, community, and government. Thank you very much, Prof. Diarso.
Yeah, thank you, Bu Nova. This is two questions, Professor. I think one is related to the social problem, and then the second one is about your opinions also, Professor Daniel. So please.
Okay, I would like to thank you, Gunova. I'd like to answer your second questions. I've been following the negotiation, the debate on climate change in various fora, including the COP. I think we just completed COP27, and I've been going all through the COP. I missed only one. So I've attended COP1 until COP27. I missed COP8. So with that experience, so one thing I learned is that, when one is trying to resolve the problem of climate change globally, yes, we can do from the sing side. What I mean by sing here is like mangrove, like forest. If you don't cut, you will avoid emission. If you let it grow, it will sequester or sinking carbon dioxide. So this is the sing. But the bulk of the problem of climate change is from the source. And namely the burning of fossil fuel. That's the biggest problem. Of course, developing countries need to, continue developing by, removing forests, cutting forests to do something which is more high yield in terms of return, economic return. That's fine, but avoiding deforestation only for not growing the economy is not a wise thing to do. So reducing emission from deforestation can be done if you do not sacrifice your economic growth. This is the understanding from the policy perspective. But sometimes it's also misunderstood. We try to identify ourselves as developed countries. Developed countries has more responsibility. With the document called NDC, you can see how much we should be reducing compared with, let's say, United States. It's hugely different. And why? Because the emission from the source in developed countries are very big. The word, the globe now is deficit of surplus of emission by the amount of 55 billion tons a year. So if we have to make it 1.5 degree in 2030, not 2050. So the IPCC assessment report says that we already increased our temperature from the industrial period of 1.2 today. When it was published, it was 1.1 in 2021. Now it's 1.2. And in the next 8 years or so, we have to keep, reducing emissions so that it will be 1.5 only. But we are in a big danger that we will not be able to meet this target because the commitment in reducing emission from the source is not very strong. I just published an op-ed, opinion in Compass this morning. If you have the chance to read it, you can see how desperate we are to ask developed countries to reduce their emission. We are in a very bad shape. Okay, so our very bleak. But what can we do? It does not mean that we are masabodo. We should be able to be part of this global community to contribute. We are good in reducing the emission from the same. Indonesia has been the leader in the follow net sink idea, making the sink becoming net sink and no longer emitter of greenhouse gases. A number of policy has been implemented to reduce emission by avoiding deforestation, by improving the hydrology of peatland, which is keep degrading and drain and emitting. A lot of effort has been done, and we will continue to do that. And Indonesia has been demonstrating a good leadership on that area. How can community be part of this? Talking about mangrove, for example. Again, when you bring the message to the community, local community, don't talk and start your conversation about carbon. I've been working, in many places. I have 49 stations in Indonesia and working in 25 countries on mangrove. We never talk and open our conversation about carbon with local community. The best approach to do and to convince them that they are going to do well and they are going to be well is their livelihood. So if you keep mangrove, if you keep coastal ecosystem intact, and you will be resilient for any, abrupt change, including climate change, food security, etc. You can link it like the SDG boxes I showed earlier. That's local agenda. That's the thing that we should send a message to them and also to the local and central government. We have our people in the center of our debate. So let's do that more rather than, while keeping on this emission reduction. That's can be number 2 or 3, but the agenda is our own local people welfare, and this kind of stuff should be prioritized. Thank you.
Hopefully that's already Ibu Nova question, Professor Daniel. It's very interesting. I just want to continue a little bit for the NDC, especially for our country, Professor. How about we keep how much that we need to keep the mangrove right now, Professor? Just a simple question. I would like to know about our NDC.
Well, to be honest, I've shown you the document called Enhanced NDC submitted to the UN FCCC in February this year. Mangrove is not part of the mitigation sector, but it is mentioned and described there very extensively for the adaptation. That's okay. This is a living document. Next year, 2023, the UN will do what is called global stock taking, and every country will be picked, in terms of their commitment to reduce the emission, and we can improve the next NDC reporting by including mangrove for the mitigation as well. But adaptation and mitigation are equally important now under the Paris Agreement. So this is a good thing with the negotiation, despite all this calamity and frustration.
Okay. Yeah. Thank you, Professor. Okay. So we have 2 questions from the audience. We have Dr. Muhammad Nur Cahyadi. Pak Nur, you would like to answer to ask to keynote speaker?
Yes, thank you very much, Bu Warma. I would like to ask Professor Heri for global radiation. It is very interesting that solar radiation is affected to the temperature. And I think this is in the atmospheric layer. In our research, this is affected in ionospheric layer and global effect. I would like to ask Professor Heri that the solar radiation also global effect or only local effect? I mean, only in Indonesia or in certain island, for example, only in Kalimantan or Java. Is it also in global? How about this case? Thank you very much.
Yeah, this is a question for Professor Heri from Pak Muhammad Nur Cahyadi about the result of the study, Professor. Yeah, so please.
Yeah, thank you very much, Pak Nur. So as I already mentioned that the idea and also the most of the research about SRM research are currently a lot have been conducted in developed countries, and what they look is that, of course, they do the research about the deployment and so on, and also the impact, And regarding the impacts, what they do so far is mostly the impact globally. So there are a lot of papers already try to see about the impact of solar radiation management deployment to a global world. But the problem is that with the global impact, the resolution is very low, right? I mean, they use data with a very low resolution, which means that we cannot generalize, we cannot get really in specific information about what will be the impact of this deployment to any specific region or local. That's why through the decimal project, they try to involve the developing countries in this research. And yeah, in the local scale. Local scales means that this is a country level, like Indonesia, Malaysia, Argentina, South Africa, and so on. So this is what happened right now.
Yeah, hopefully that is answer the question from Nur, Pak Nur. So
Yes, thank you very
Professor.
much. Yes, Professor. Yes, this is global. Yeah, thank you very much.
Yeah, welcome.
So Prof. Ikap would like to raise the question. Prof. Ikap.
Okay, thank you, who are as the moderator. Thank you very much for the very excellent presentation from Prof. Daniel Murdiarso and Prof. Heri Kuswanto. So first, as I mentioned through private chat to Prof. Daniel, that we at the Center of Marine Earth Science and Technology just published a paper actually about mangrove management, a case study in Malaysia and Indonesia. I would like to share that paper to you, Prof. Daniel. What I can say that there's a good example in Malaysia. They use a 3-in-1 system. So the big mangrove forest actually is separated into 3 areas, which one area can be taken the wood to produce charcoal, etc. And after finish one and move to the other one and rebuild actually made to the previous taken forest, and it maintains for many years. Okay, I believe it is a good example. Maybe we can try in Indonesia. The other one actually is a case in Surabaya, but just a beginning. Okay, that's the point I would like to say to Prof. Daniel. And my question actually related to Prof. Heri, because what Prof. Daniel Murdiarso and his colleague and his team from mangrove people have done so far actually said what we call the growing of mangrove can be done massively. For example, one initiated by G20 last time in Bali. If it is a success, what happened with your model? Can it be speed up when the mangrove growing all over the world can be increasing massively? Okay, thank you.
Yeah, thank you, Prof. Ikap. This is the comment for Professor Daniel, and also the possibility maybe Professor in the future have the collaboration with ITS especially. And then also for Professor Heri, the question from Prof. Ikap regarding to the what is already modeled by Professor Heri, and then what will be the impact if the activity for Professor Daniel is already can grow out, for example. Yeah, so please the comment from Professor Daniel first and then Professor Heri.
I didn't get the question, sorry, Pak Ikapu. Maybe you're asking about carbonization of charcoal or wood or something. Sorry, I didn't get it.
Yes, I didn't have really a question actually for you, Pak Daniel. Just a note that we have work related with managing mangrove. Perhaps we can discuss later. I mean, the 3-in-1 system developed in Malaysia is very nice if can be implemented in Indonesia. And the case like in Demak can be avoided in the future.
Thank you, thank you.
Okay,
Will do.
Thank you.
Yeah, thank you, Prof. Daniel, and then Prof. Heri. So the question from
Yeah, thank you, Prof. Ikap, with the questions. So as already mentioned also that the idea of solar geoengineering or solar radiation management is not replacing the current emission scenario. So this is the substitute of, right? So which means that if the scenario goes very well, like what you already mentioned about if the mangrove grows massively, then of course we can expect that the target of having the temperature increase below 1.5, as already mentioned also by Prof. Daniel, by 2030, we expect that it can be achieved faster than just do a usual business as usual. So this is what I can answer. Yeah, because the SRM, the way of doing the SRM experiment, following the pathway of the emission scenario.
Yeah.
Okay, thank you.
Yeah. Yes. Prof. Heri, before this is end, I would like to ask one question only because it's a very interesting. I saw in your map. This is related to the Borneo Island because Professor Daniel also previously talked about the Professor Daniel worked a lot in the peatland. I also saw that based on your model, the temperature, if there is no solar SRM, so the temperature in the Borneo Island will be increased remarkable, as I saw in your map. So it's very dangerous to the land, especially if it can be possible to, because you show the application of the SRM after that. So then the temperature is decreased, but mostly it will be decreased in the sea area, but not in the land area. How about that, Professor Heri?
Yeah, so actually this is one of the questions that we raised in our paper. We leave this question as the future for the future investigation. So unfortunately, we haven't yet tried to look at what happened with the climate system, especially why the result of the the result of the SRM deployment will be different between land and ocean. So we still need, of course, to collect some proof or some references in order to answer these questions. So this what we present so far is okay. This might be what happened, but looking back behind the reason why it happened, so we are still researching out about this one. So that's what can I say, Bu Arma.
Yeah. So hopefully that in the next future, Professor Heri will be have this kind of the research in the future again that try to modify maybe for the land condition, because it have a big problem to us. So thank you very much, Professor Daniel and Professor Heri. So hopefully that all of the audience already get the message from Professor Daniel and Professor Heri today, because it's a very wonderful talk in this morning. And we can have the token appreciation first to Professor Daniel, because Professor Daniel will be have a class at 11, I think. Yeah. So please, for the host, we can share this is for Professor Heri.
Thank you.
We can give applause.
Thank you very much.
Yes, and
Thank you,
then
Prof. Heri.
it's could you share for Professor Daniel? Yeah. So this is for Professor Daniel. Professor Daniel, thank you very much.
Thank you for the certificate. Thank you very much. Enjoy the conversation.
Yeah. Thank you, and hope that next years can
Thank
come
you,
to
Prof.
ITS
Daniel.
in
I
person.
will. Thank you. Bye-bye.
So thank you very much. So Professor Heri.
I have to leave now. Sorry about that.
Thank you.
Thank you, Prof. Daniel.
Bye. See you. Bye.
Bye-bye. Professor Heri, I'm so sorry because some of the questions still rise in here, Professor. So we have some question to Professor Heri. I think it's offered by the committee asking to me to mention about the question. So, okay, for the first one, they're asking about the technology, because you show the balloon first one in the global north area, right, Professor Heri? But in the south global area, is it possible to use this kind of the technology similar with what the Harvard University conducted? This is the first from the audience. And the second one is regarding to the SRM. So about the validity of the model, especially because you are using the model in here, how about the validity of the application of the application of the model and the application with the SRM, solar radiation modification, in your result? Because you show previously, like I'm asking, in the sea level and then the land level. So how about the validity of the model? So this is the two questions from the audience. So please, Professor Harry.
Okay, thank you very much. So very interesting question. The first question is about the equipment, right? So
Yes,
so far, research about the development of the equipment is still limited to some institutions in the developed countries like US. I know from the previous conference that there are also US private company who try to develop the to build the specific plane that can be also used to transport the materials. So the one that I just showed you is the from Scopec projects run by Harvard University. So what they try to make another way by creating the balloon for the transportation. But of course, this is not an easy and cheap technology, right? So creating or developing the balloon itself is very expensive. So yeah, that they already mentioned about the total cost of the establishment of this equipment. So developing countries right now is still involved in the researching the impact, because again it's very sophisticated and this is very expensive technology, and also the deployment itself will be in the atmospheric level, which means that I don't think that it is necessary for us as a developing countries to build this equipment by our own, because the development has already been set up by throughout the equator line, which also covers the points above the developing countries itself. So developed countries have already tried to make it, but I'm not sure for us. So far, there is no effort for us in the developing countries to build this equipment. And then about the validity. So yeah, the result that we presented here based on the simulation. Yeah, no worries.
Yeah, okay.
Based on the data set that we collect from some sources, especially open sources, and yeah, bias of the data would be one of the issues that we need to overcome first. So that's why from our research, we do the bias correction in order to get the data which will be able to characterize the local characteristic of the region. So this is the first thing that we do. And I already mentioned also that regarding the validity of the models, there are some experiments have been done regarding this the deployment of the SRM, and this is they use different prescription also about the deployment, and we know that this is one of the sources of the uncertainty. So when someone asks which model that will be the best to be deployed, so this is still big questions, because each of the model bring their level of uncertainty. So yeah, what we can say is that if we deploy this scenario, this will happen. If we deploy this scenario, this will happen. But we cannot justify, oh, this one is the best scenario. So there is no reason that we say that so far.
Okay. So this is based on the scenario itself, right, Professor?
That's right. Yeah.
Okay. Okay. Thank you very much, Professor Harry. Hopefully that is answered the question from the audience, especially. So then Pak Aji would like to raise some question to Professor Harry.
Yes, please. Thank you very much. Yeah. Hello, Prof. Heri. Assalamualaikum. Yeah, thank you very much for your very nice presentations. And I think my first question is already asked by Pak Nur Cahyadi about the impact of the SRCM, solar radiation management. Yeah, to continue that questions, I just want to know about, is there any special cautions if we apply this kind of engineering-based solution? Because I'm still worried about the impact sides of this technology because we have natural and globally phenomena caused by climate change. And then the second one is about the results of this modeling. Will it be possible to have an access? Yeah, is it open source or open access for other researchers? So maybe I can encourage our research centers member to involve in this research. Thank you very much.
Okay. Should I answer that, please?
Yes, Professor. So because
Okay.
this is a research center also that we work together.
Yeah, thank you, Pak Haji. So you are worried about the impact of the SRM. I think this is very normal. It's quite normal. So whenever we talk with someone that just know about the idea of SRM, they think about, oh, it must be very dangerous, especially what will happen with the health is because you imagine SO2, sulfur is a chemical thing, right? So when we inject in the atmosphere, there will be impact to the human health, for example, or to the respiration or something, right? But in fact, the research has already been done regarding this one. So the materials that injected in the atmospheric level would not that dangerous. Means that yeah, there is some chemical reaction that will happen in the level of the atmosphere, and it will not goes beyond the Earth itself. So there will be no impact, no issue in this case. I mean, there are already some publication which try to confirm that using these materials will not create a dangerous to human health. So this is one thing. So and yeah, but of course, SRM will give an impact, right? So to some other fields like the climate extreme, and then to the malaria distribution. So yeah, as the some research I already shown in my my slide. And about the modeling, so all of the data set that we use so far for doing this research are open access. So we can just easily access to the data of the experiment, G4, GeoMIP, and then we have also GLANCE. So later, if you're interested to do research in this area, we can discuss in more detail about how to access the data set and so on. But basically, they are open access data set, and we can simply download this and do some preliminary pre-processing to the data set in order to get some good result. Yeah.
Yeah. Thank you very much. Yeah, I think this is also one of the research that can be conducted in the research center, right, Pak Haji?
Yeah.
So together with Professor Heri and also in the Professor Ikap Research Center. So thank you very much, Professor Heri Kuswanto, and all of the audience. We already approaching the end of the seasons for the first seasons, and again we give applause to Professor Heri and also previously Professor Daniel. Is a very lovely talks today, and then this is also the inspiration talk that we can continue for the research and also for the community services in the future, because previously already mentioned by Professor Daniel, right now it's the term for the young to become rice and also keep the ecosystem and our life is meaningful. So thank you very much, Professor Harry, and then I give it back Master of the Ceremony. Thank you. Big applause to Professor Harry.
All right. Thank you, Mrs. Warma, for moderating this current keynote speech, as well as Professor Dr. Daniel Murdiarso, as well as Professor Heri Kuswanto as the first set of keynote speakers. Thank you very much once more. Checking back on the time, it is best for us to have our break in a short moment. However, before we take a break, we would like to inform you that the next session will be the parallel session. The committee will enable access to 7 breakout rooms, catering to 6 different topics for you to hear panelists elaborate their full paper. The breakout rooms are as follows. Room number 1 will be sustainable construction. Room number 2 will be community resilience and empowerment. Room number 3 will be tech and management related to marine and fisheries resource. Room 4A and 4B will be marine and coastal area pollution from wastewater, nutrient, and marine litter. While room 5 will host disaster risk management topic, while in room 6, it will be a mixed topic. In conjunction with the new nature of the session, allow me to reread. Apart from that, I would like to circle back to the rooms. Here are several of the presenters that will present within each of the rooms. Hopefully, participants who would like to survey more on the topics may join later on in each of the breakout rooms. In conjunction with the new nature of the session, allow me to reread the conference protocol with a slight adjustment for the next session. First of all, participants are kindly reminded to rename the display name of the Zoom participant ID as shown in the screen. For example, Kevin_ITS Surabaya _4A. And in addition, please, we would like to remind you again to turn on your camera throughout the conference, particularly within the breakout rooms, and use the virtual background listed on the link. Second, participants are requested to be dressed and to behave in a polite manner. Thirdly, participants are requested to mute their microphone along the duration of the online conference, particularly the breakout rooms. But during the question and answer session, when allowed by the moderators, will be able to unmute their microphones. Number 4, participants are reminded to kindly set the online conference environment to be comfortable and optimal for camera activation in terms of backlight. Number 5, participants are recommended to make sure the internet connection is stable along the online conference. Number 6, participants are recommended to use headsets or earphones to minimize noise. And lastly, participants are prohibited to distribute the link in any way or form to any individual, party, or institution. For further mechanisms of the presentation, I would like to explain in a glimpse that each session will be hosted by a chairperson and assisted by a co-chairperson. Secondly, the chairperson will be sharing the presentations according to the schedule and assisted by the co-chairperson himself. Thirdly, each presenter must be in the breakout session rooms for his or her presentation on time. Fourthly, the presentation by participants will be done using pre-recorded videos or using PowerPoint slides. 5, the co-chair will play the pre-recorded video presentation, or the participant will share their PowerPoint presentation. 6, the presentation will be conducted within a 10-minute time constraint and will thereby continue with a 5-minute Q&A session. And lastly, the session will be documented by the co-chair. We will start the conference back at 1 p.m. Please kindly be reminded. May I repeat once more that the conference will start again before 1 p.m. Please kindly be reminded that the breakout rooms will already be opened during the start time of the parallel session. Hence, we would like to ask presenters and participants alike to be ready 15 minutes prior. On behalf of the Third Sustainability and Resilience Coastal Management Joint International Conference Committee, have a great break.